We got some double angle identities, and these are trig formulas which involve double angles. So, for example, 2 theta as opposed to just theta. Okay, so double angles, it's double the angle. And just to clarify what an identity is, so an identity is like an equation, except it is true for any value of the variable. Okay, and that differs to an equation because equations only hold true for certain values of the variable. So just to kind of clarify what I mean, this is an equation. You can all see that okay? What I've just written. And what is this? This equation is true for only one particular value, which is x equals 2. Okay, so that is an equation. It's only true for this value. Whereas an identity, and you've already seen trig identities before, so like this one, sine squared theta plus cos squared theta equals, what does it equal? 1. So you've seen this is an identity, okay? Now it's like an equation, except it holds true for any value of theta. If I was to put in, let's say 45 degrees, what's sine of 45? Yep, opposite over hypotenuse, 1 over root 2. So sine of 45 is 1 over root 2. So sine squared is 1 over root 2 all squared. What's cos of 45? Still 1 over root 2. What's 1 over root 2 squared? Yep. So I've got 1 over 2 plus 1 over 2, which equals 1. Okay. So that's true for 45. It's also true for 60. It's also true for 44. It doesn't matter the value that I put in here for theta. This is always going to be true, okay? Whatever the value is. Okay, so that's what makes an identity an identity. It's true for any value of the variable. And sometimes you may see, instead of writing an equal sign, they might write 3 little lines like that, okay? And that just means it's an identity. But they don't particularly mind if you use like a normal equal sign or the 3, okay? 3 just means it's an identity, but it doesn't matter which really you use. Is that okay with everyone? Tells us what an identity is. Okay. Let me just get rid of this now. Can I do that quickly? Okay, so our identities. Okay. The identity that we're going to show, there's a few of them, but we're only going to prove one of them, is cos 2 theta equals 1 minus 2 sine squared theta. Okay, so this is the one that we're going to prove. Now, like I said, higher level have done this already, but they did it a different way. This is another way that we can do it, and SL, you have to just be aware of this, okay? They may ask a question which is to do with showing this result. Also, just to show you, you are given this in your formula booklet. You're given all these formulas, so you do not need to remember them, which is good, but you do need to know them and know where they come from. So I put a new channel in the 18th to the 29th of May. Formula booklet. And if we go down to, there's so much good stuff in here. Page 7. Yep, let me zoom in a little. Okay, so yes, standard level. Here we go. Double angle identities. Sine 2 theta equals 2 sine theta cos theta. And the one that we're going to show is this one. Cos 2 theta equals cos squared theta minus sine squared theta, which also equals 2 cos squared theta minus 1, which also equals 1 minus 2 sine squared theta. So these are things that you are definitely going to need. You're going to have to use them at some point. You don't need to remember them. They are here for you, okay? So let's go ahead and prove this result. Is that okay with everyone? Am I going too fast, too slow? Okay. Excellent. So let's go back. Okay, so we're going to start off with this diagram that I've drawn out. I've got a couple of triangles. This is side 1. This is also side 1. So AB is 1, AC is 1. The angles that it makes with the horizontal is both theta. So both these triangles are identical, okay? They're exactly the same. Okay, ABD is the same as ACD. And what we're going to do is, what are we going to do? Yeah, we're going to look at length BD. Okay, here is, so can everybody see B and D? I know it's quite small. Okay, so we've got a right angle triangle here essentially. If I'm just looking at the triangle ABD, what is BD equal to? If this side is 1 and this is theta. I'll give you a clue. Sine theta equals. Sorry? What's sine theta equal to? Yep, which is? What's the... Sorry, yeah, this is a D. Okay, so this is a D in the middle. So I've got a B up at the top, a D here. So BD over BA, and what's BA equal to? 1. Okay, so BD is equal to just sine theta. Is that okay with everyone? Okay. And because BD equals BC, yep, because these triangles are identical, the length BC is equal to what? If this is sine theta and this is sine theta, then the total length is just 2 sine theta. Okay, so BC, total length of this triangle is 2 sine theta. All right, so that's one result for BC. Okay, the next thing we're going to do is we're going to look at BC, but we're going to use the cosine rule. So perhaps if I redraw. So I'm going to take my blue triangle. Let me just redraw. And for my blue triangle, I've got, so I'm just redrawing it outside, A, B, D, sorry, A, B, C. This is length 1, this is length 1. What's the angle in between here? Two theta. Okay, so I've just taken this blue triangle and I've just redrawn it down here. I haven't included the line going across, okay, the horizontal. So if I was going to use the cosine rule on this, I've got two sides and the angle in between. So it would be BC squared, so this side squared is equal to this squared, AB squared, plus AC squared, minus 2 times AB times AC times cos of the angle in between the two sides. Is everybody okay with me using the cosine rule on this triangle to find out this side, BC? Darius, Tyler, Jesse, Jake? Jake can't hear me. Frankie? We all good? We sure? Shout if you're not. Okay, well let's keep working through this. 1 squared is 1. 1 squared is 1, so this gives me 2. Minus 2 times 1 is 2. So BC is also equal to, well, BC squared is this, so BC is the square root of it all. Is everybody okay with that? So we've worked out this length of BC 2 different ways and got 2 different results. What do you think we're going to do next? What do you mean? Just clarify. I think you're right. Mm-hmm. Yeah. Yeah, just... Yeah, absolutely good. 2 sine theta equals BC. It also equals this thing. So they both equal each other. Good. All right, let's keep going with this. Oh, what have I left off? 2 theta, isn't it? Yeah, my bad. 2 cos, 2 theta, 2 theta, 2 theta. Okay, so we want, our aim here is to get a formula in terms of with a double angle, okay? So here's my double angle. So I want to try and get this cos 2 theta by itself. So if I want to get this by itself, what do I have to do first to both sides? I want to get the cos 2 theta by itself. What do I have to do to both sides? Say again? Yep, square first. Okay, I'm going to square both sides. So if I square the left-hand side, I'm going to get, well, 2 squared is 4. I'm going to get sine squared theta. When I square all of this on the right-hand side, I'm going to get Yep, I'm going to get 2 minus 2 cos 2 theta. Right, so remembering I'm trying to get cos 2 theta by itself, so what would I do next? Let's have somebody from SL. I want to get the cos 2 theta by itself. Yep. Good. I'm going to take this 2 away from both sides. Thank you, Frankie. So I get 4 sine squared theta minus 2 equals negative 2 cos 2 theta. Now what? Somebody else from SL? Sorry. Yep, divide by negative 2. Good. So divide this by negative 2. Divide this by negative 2. Divide this by negative 2. Good. When I do that, I'm going to get, so 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is positive 1. And on this side I'm left with cos 2 theta. So my formula is cos 2 theta equals 1, subtract 2 sine squared theta. And that is one of the formulas that is given to you in the formula booklet. And it's the one that we were intending to show. Does that make sense? You know, it's nothing too crazy. It's just using the trig formulas, it's using cosine rule, and then it's just a little bit of algebra to manipulate these things. Now the other formulas, or I'll just write them down for you, and then I'll let you go and do some practice on this. The other formulas that are given to you are cos 2 theta equals 2 cos squared theta minus 1. Cos 2 theta equals cos squared theta minus sine squared theta. And sine 2 theta equals 2 sine theta cos theta. And like I said, you don't need to remember these, but you must know how to use them for certain questions, okay? In formula booklets. And once you know this result, you can easily prove these ones by using the fact that you know that sine squared theta plus cos squared theta is equal to 1. Okay, you just use some substitution and these results will come out. Okay, I recommend giving that a go. All right, just a couple of, just a little question to kind of get you going, and then I will leave you. If, let's say, yep, sine theta is equal to 3/5, and theta is less than 90 but greater than 0, find a few things. I want you to try and find cos theta. I want you to find sine of 2 theta. I want you to find cos of 2 theta. And tan of 2 theta. Okay, so using these results in some way, I want you to find these answers, okay? Do you think you could quickly do that for me now? Your silence I will take as a resounding yes. Excellent, absolutely. Okay, I'm going to pause recording. Before a square root, I've got 9/25 plus cos squared theta equals 1. Yep, I'm going to subtract 9/25 from both sides. And if this is a calculator paper, you would have to do that without a calculator. I'll do it over here. You'd need a common denominator of 25. Look up the how-to videos if you need help on subtracting fractions. 25 take away 9 is 16. So cos squared theta is 16/25. What is cos theta? Yeah, 4/5. Square root the top, square root the bottom. Is that okay? Now the other way you could think of it, exactly the same, is that these sine theta equals 3/5. What does sine theta in a right angle triangle is opposite over hypotenuse, correct? So if this is a right angle triangle, then using Pythagoras, this side has to be 4, because it would be 5 squared take away 3 squared. And cos of theta then would be 4 over 5. So that's just another way that you could think about that one. Okay, to get you started on the second one, I've got sine 2 theta. Which one of these formulas do you think I'm going to use for this one? SL? And not Sam or Frankie. So that means Darius or Tyler. Which formula am I going to use? Yep, that's the only one I can use. So I've got 2. What is sine theta? Yep. What is cos theta? I've just worked it out. 4 over 5. What is 2 times 3/5 times 4/5? Without a calculator. Nope. Say again? Nope. Yep. 2 times 3 is 6. 6 times 4 is 24. 5 times 5 is 25. Alright, the third one, you can use any one of these formulas you want, okay? Because you're just going to be squaring things. And for the fourth one, tan 2 theta, well, what is tan? What's the other identity for tan theta? It's also equal to sine theta over cos theta. So tan of 2 theta is sine of 2 theta over cos of 2 theta. And it's just a question of putting your values that you get for this one and this one into it, okay? And knowing how to divide fractions. Do you think you could do the last two yourselves if I leave you to it? Also, just a reminder that in here, how to, if you need a recap, which I think some of you do, add and subtract fractions, multiply fractions, divide fractions. These are 2 up to 4 minutes long. Okay, I would recommend having a look at those. And some of these other videos on, it should be, it's the basics really that you should know how to do. I don't have to remind you that one of your exam papers is non-calc, so you have to make sure that you're pretty fluent with doing these things quickly and correctly. Okay, so I will, is that okay? Does anybody need me to go through anything else there? Nope, okay. Well, once you've had a go at both of those, you can have a look. SL on page 522 and exercise 12F, as well as having a go at some exam questions that are posted in the channels. Okay? You send me exam questions, I will happily mark them, I will happily send you solutions. If you don't, it's only going to, you're only going to make things more difficult for yourselves.